Okay, welcome to Chapter 3, Lesson 1, Constant Rate of Change. Our learning target or objective is to identify proportional and non-proportional linear relationships by finding a constant rate of change. And we have a few vocabulary words for this lesson. Our first one is linear relationships. Relationships that have a straight line graphs. And our other vocab word is constant rate of change, when the rate of change between any 2 points in a relationship is the same or constant. Okay, once again, you may always pause the video to write down the definitions and then resume at your pace. Okay, we're going to look at linear relationships. As per your definition, constant rate of change. So let's take a look at, we have number of songs and number of minutes. Let's look between the top, the number of songs. We go from 0 songs to 2. So our change, as we look through there, is plus 2. And we go from 2 to 4, once again, change is plus 2. From 4 to 6, our change is plus 2. 6 to 8, plus 2. So we'd say our rate of change is plus 2, so that would be constant because it's the same all the way through. So we have a constant rate of number of songs. So now let's look at our minutes. Our minutes go from 0 to 1, so it has a change of plus 1. From 1 to 2, it has a change of plus 1. From 2 to 3, once again, plus 1. And from 3 to 4, plus 1 once again. So looking at just our minutes, looking at the time, the rate of change is 1 every time. So that would be a constant rate of change as well with the time. You do not compare the number of songs change to the minutes of change. You look at that individual one, so the x's. So you have time is x. X has a change of 1. The y has a change of 2. Make sure that's what you're comparing. You're not comparing the minutes and the songs, because those rates do not compare, but they are similar because they have a constant rate. Okay, look at an example now. The balance in an account after several transactions is shown. Is the relationship between the balance and the number of transactions linear? If so, find the constant rate of change. If not, explain your reasoning. Okay, once again, let's take a peek. We're going to look at number of transactions first. We go from 3 to 6. So our change is 3. 6 to 9, once again, our change is 3. From 9 to 12, our change is 3. So our number of transactions had a constant rate of change of 3. Now let's look at our balance. Our balance went from $170 to $140, so it had a change of minus 30. It went from 140 to 110. Once again, it had a change of negative 30. And the last transactions went from 110 down to 80, which that also has a negative 30 change. So if you see our balance all had negative rate of change of negative 30. So once again, that is constant. I may do it, set it up like this. We had negative $30 per 3 transactions. Or if we reduce that, negative 30 divided by 3 is negative 10. So you had a withdrawal of $10 per transaction as an average. Okay, once again, any questions that you may have, please write them down on your video sheets, bring them into class, or review the videos once again. Okay, let's go on to our next slide here. It's a key concept. And our key concept tells us proportional linear relationships. They are two quantities, A and B, have a proportional linear relationship. if they have a constant ratio and a constant rate of change. Symbols, B over A is constant, and change in B and change in A is constant. So we're going to take a peek at this key concept and then a real-world example on our next slide. And here we go. We're going to use the table to determine if there's a proportional linear relationship between a temperature in degrees Fahrenheit and a temperature in degrees Celsius to explain our reasoning. Hey, first let's look at the degrees of Celsius. We're going to take a peek to see what the rate of change is and see if it is constant. We go from 0 to 5, so you have a +5 rate there. From 5 to 10, we're looking good, it's +5. 10 to 15, once again, +5. And from 15 to 20, +5. Okay, let's look at degrees of Fahrenheit. From 32 to 41, that is a 9-degree change. 41 to 50 is a 9-degree change. 50 to 59, 9-degree change. And 59 to 68, once again, a 9-degree change. Once again, all of our changes are constant, so we have a constant rate of change in degrees Celsius as well as Fahrenheit. Okay, now since we've determined that the constant rate of change of degrees Celsius and the rate of change is constant in degrees Fahrenheit, now that determines since they are constant, this is a linear relationship, and we will appear on a straight line. But now let's see if they are proportional. How we're going to determine if they're proportional is we're going to put them in fraction form. So if you look on the right side of the screen, degrees Fahrenheit, we had 41 degrees. Degrees Celsius was 5. You put that as a fraction. We divided 41 divided by 5. You got 8.2. So to see if they're proportional, when we divide 50 divided by 10, it should be 8.2 if this is a proportional relationship. 50 divided by 10 is 5. And then we tried this 59 divided by 15, we got approximately 3.9. So as you see, when you divide them, they are not coming out the same. So that means they are not proportional. But let's look at the graph. Graph shows our linear relationship. As you see, our 5 points all appear on the same line. That means all these points have a linear relationship, but they do not have a proportional relationship because they are not the same distance apart. We have 8.2, 5, and 3.9 approximate. So here we have a linear relationship, but we do not have a proportional relationship. So the constant rates of change are in both. The constant rate of change in both degrees Celsius and Fahrenheit are x and y. You are going to have a linear relationship, but to have a proportional relationship, when you take one divided by the other, each x and y should have exactly the same answer. This does not. Okay, any questions, please write them down, review the video, as we will be going over more of these examples in class.